Types of adsorption. On the basis of the forces of attraction which develops between adsorbate and adsorbent, the adsorption can be classified into two major categories. The two categories are physical adsorption and chemical adsorption. This physical adsorption is also called physiosorption, and it's also called chemisorption. Now, let us understand both of these one by one. Let us understand first physiosorption. Now, what is exactly this physiosorption is? It is the type of adsorption in which the forces of attraction between adsorbate and adsorbent are weak van der Waals forces of attraction. They are weak van der Waals forces of attraction because mainly the forces are not strong. So, therefore, since the forces are weak, that we call it a sort of a physical attraction, just a simple physical attraction which can be removed easily, and that is why the energy release in this type of adsorption will be less. So, the second point most important is that the enthalpy of adsorption in these cases is from minus 20 to minus 40 kilojoules per mole. You need to understand minus signs means the energy is given out. So, the energy given out is very less. Now, other thing which is very important, such type of adsorptions are non-specific. Non-specific means what? They can take place on any type of surface because these van der Waals forces or dispersion forces can be formed by any type of substances, any type of surfaces, because they are formed mainly by instantaneous dipoles. So, they can be formed by any surfaces. So, that is why they are non-specific. Moreover, they are reversible. These types of adsorptions are reversible. See, if I am writing down this with marker, I can remove it with it if simply by rubbing it out. So, this is again is an example of a physical adsorption. It is a reversible. The gases which are adsorbed on the solid substances, solid surfaces can easily be removed. And that is why what we find is, like we have seen, like when we do the distempers in our houses, what we find is the persons have to first rub out the already the distemper which has been done. Why they have to rub out that one? The reason is because if the new distemper or new whitewash is actually put up on the earlier one, actually you are not putting that distemper or the layer of a paint or a whitewash on the earlier one. You are putting it on the layer of the gases which are adsorbed on the surface, which are not visible to you. And that is why during summers, when the temperature is very high, this much of energy is already there in the environment. Therefore, those gases, they leave the surface, desorption takes place, and those layer of paints or whitewash or distemper which are there on the other side of those gases, they comes out in the form of scalps. That is why you need to rub out those gases. You need to rub out the earlier distempers so that whatever the layer of the paint or the distemper or the whitewash you are putting up, so that it can form a more stronger bond with the surface. So, these are the certain properties. There are few other things which are very important, like I told you, non-specific, reversible. There are other things like physical adsorption. It always decreases with temperature, because minus 20 to minus 40 kilojoules of energy can easily be provided at room temperature. And now if it goes beyond that, simply what we notice is desorption takes place. The gases starts escaping out, leaving the surface. They just bounce back. So that's why this type of adsorption decreases with the temperature. Another thing which is important to be noted, that they when we see the pressure, they increases with the pressure. So they increases with pressure, because more the pressure you apply, they keep on adding. There is one more which is very important in this case, is that this type of adsorptions are multi-layered, because they are non-specific. Once the layer is formed, we can have another layer of the gases adsorbed on it. We can have then another layer of the gases adsorbed on it. We can have another layer of gases adsorbed on it. So it's always this multi-layered, because it's non-specific. So these are the major points of physical adsorption. Let us see now what is the chemical adsorption is. Now let us understand chemical adsorption or chemisorption. It's the adsorption in which very strong or forces of attraction develops between adsorbate and adsorbent, which are almost of a nature of a chemical bond. These forces are as strong as a chemical bond is. So what we find is, when the forces of attraction between the adsorbent and the adsorbate are very strong, almost of a nature of a chemical bond, the adsorption is called chemisorption or chemical adsorption. The most evident thing in this case is, therefore, since these forces formed are very, very strong, a lot of energy is released in this process. Therefore, the enthalpy of adsorption in these cases is minus 80 to minus 400 kilojoules per mole. That's very high. And if it's a range of minus 800 or 400 kilojoules per mole, it's almost equivalent to a chemical bond, very strong bond, covalent bond. So we can understand the forces are almost like a bond which is formed between the adsorbent and the adsorbate. Moreover, remember, they are highly specific. Highly specific means what? This type of adsorption can't take place on any type of surface, because the surface has to be very specific about it. It has to be very activated in the sense that it can only form this type of forces with certain other adsorbates. So they are highly specific. This can't take place on any other surface or on all the surfaces. So it's highly specific. And what we find is, if this type of adsorption has taken place, these type of adsorptions are irreversible. We cannot just by rubbing them that we can just take them out. It's not possible. They are irreversible. They are very strong. And then what we find is, they first increases and then decreases with increase in temperature. They first increases and then decreases with the temperature. The reason is, till we are heating to a certain temperature, when the energy provided is acting as an activation energy. Then beyond a certain temperature, it starts again decreasing, because the desorption starts going on. So it first increases and then decreases with the temperature. That's the basic points we have in this case. And remember, this type of adsorption is always unilayered. It's single layered, because it is highly specific. So this is what is the chemical adsorption is. Now, after understanding these two, now let us understand Freundlich's adsorption isotherm.